Alright, so I'm going to show you a little bit about implicit differentiation. So why will we need to do this? Well, what we can use this for is we can find rates of change of functions that you can't really, it's hard to isolate the y, so we call that explicitly solving for y. It's hard to get the y by itself. And we still want to be able to find the equations of tangent lines in those situations. And then one really big reason is that we want to be able to solve related rates problems. And that's this here. And that's section 3.10. Okay, so those are a couple of reasons. So let's get right to it. Alright, the first problem I want to show you is, let's say we wanted to find the slope of the tangent line of this particular equation at 3, -4. And we can see that, this is an equation of a circle with a radius of 5, and what we're saying is we want to figure out the equation of this tangent line right here, this one. And so one way we could do that is we could go ahead and just go with what we know, and we can go ahead and just solve this for y, try to solve for y explicitly. So that's how I'm going to kind of tackle it the first time, and then we'll take a look at the new information. So first, explicitly, what I would do is I would try to solve for y. So I would say y squared equals 25 minus x squared. And then I'd go ahead and take the square root of both sides. So that would be plus and minus 25 minus x squared. And then this is really the upper and the lower half. The positive is the upper half of the circle, and the negative radical is the lower half of the circle. And since what we're dealing with is the lower half, I'm just going to take a look at the lower half. So let me just say, lower half only for this problem. So we have y equals negative square root 25 minus x squared. Now, what we want to do is we want to figure out the derivative of this. And I think it's way better if we set this up for the power rule before we actually try to find the derivative. So let's say this is 25 minus x squared. It's negative. And it's raised to the 1/2. So now it's really set up a little bit better to find the derivative. So the derivative of this would just be applying the power rule. So we'd say y prime equals, we'd have a negative, we'd have 1/2. We take this quantity, 25 minus x squared, reduce the power by 1, so negative 1/2. And so that would be okay, but then we'd still have to find the derivative of the inside chain rule. So that would be minus 2x. So there's the derivative. Let's try to simplify it a little bit. So the 2's will cancel, the negative signs will cancel. It'll be x over, and then since that's a negative exponent, I'm going to go ahead and drop it down to the bottom and make it a square root, make it a radical, 25 minus x squared. So there's the derivative. So let's say now we want to go ahead and figure out what the slope of the tangent line is. So we would just go ahead and plug in a 3. So I guess I'll just show it here, if you can follow with me. I'm going to try to figure out what y prime of 3 is. So I would plug that in. Sorry, it's a little messy. I would say 3, because I'm plugging into the top. It would be 3 over square root 25 minus, and that would be 3 squared. And so then final answer, it's a little bit messy. Final answer equals 3 over, you can see 25 minus 9, so 3 over the square root of 16, so the answer would be 3/4. So my apologies, running out of space. I'm going to say my answer would be 3/4. And what that is that's the slope, and you can tell here that you would be going up 3, and you would go over 4, and that would be the slope of that particular tangent line. Okay? That's how we could do it explicitly. So let's take a look at today's lesson a little bit more. Let's take a look at how we could do this implicitly. So implicitly, you're taking the derivative with respect to x. So this one, x squared, is no different than it was before, so we just say 2x using the power rule. And then with the y's, it's a little bit different, because every time you encounter a y, you're always going to have to take the derivative of that. You're going to have to say, y prime. So first we use the power rule. So we bring the 2 out in front. So it's 2. Then we reduce this by a power, so that's y. And then what's different about it is we have to take the derivative of the inside function, which is y, with respect to x, and that's going to be y prime, or dy dx. It's just with implicit differentiation we tend to do y prime just because it's less messy. The derivative of a constant is 0, and now what we want to do is we just want to isolate the y prime. So we isolate the y prime, and so that's going to be 2y, y prime, and I'm going to slide the 2x over, so I have to subtract it. So minus 2x, and then y prime equals negative 2x divided by 2y, and I've got y prime equals negative x divided by negative y. And this time we actually need to plug in the x and the y to get the y prime. And remember, the point we were looking at was 3, negative 4, so of course we got the x and the y. And we're going to go ahead and just plug that in. So we've got negative 3, and the y, we got negative 4. So we get the same answer as last time. We get 3/4. Okay? Alright, let me show you another example. This one, x cubed plus y cubed equals 4. So what you do here is you would use the power rule. So we'd say 3, bring the 3 out in front, reduce that by power, and then we should be good. Derivative of the inside with respect to x is just 1, so that's why we don't have anything else. Then y cubed, we have 3, and then we reduce that by power, and then we multiply it by the derivative of the inside, which is y prime. And then the derivative of a constant is always 0. So that's what we have so far. And we're just going to isolate the y prime again. So we have 3y squared y prime. We subtract the 3x squared over and isolate the y prime. So y prime equals, and then we're going to cancel the 3, so we got negative x squared over y squared. Should be good. All right, let me show you a little bit more complicated one. All right, so let's say we've got this one, and what makes this more complicated is you actually have 2 functions here. So that's going to require the product rule. So we're going to have to use the product rule. We're going to have the chain rule here as well. And the whole process is called implicit differentiation. So what we're going to have to do is we're going to have to use the product rule here. So we're going to say derivative of the first. So the derivative of the first would be 2x. And then times the second. So that would be times y, without making any changes, and then plus, and then derivative of the second would be y prime, and then, back up. So derivative of the second, y prime, and then times the first. So there we go. That's the derivative of that one. And let me just fix my little t here so that it actually lines up. Okay. So, alright. So now let's go to the next side. So this one is also going to be the product rule. So derivative of the first, so that's just 1. And then times the second, plus derivative of the second, which is 2y, y prime, and then times the first, So this is the product rule again. And then equals, and then the derivative of the right hand side is just 3. So then what we're going to do is we're going to try to get our y primes together. So we've got y prime x squared plus 2y prime x equals, we got 3 minus 2xy and then minus y squared. And notice we've got the y primes here, so I'm going to factor it out of the left hand side. So that would be x squared plus 2xy or yx. And on the right side, I'm going to just leave that alone. And last thing is just to divide by this quantity here. So x squared plus 2xy. Okay. And that will isolate the y prime, and that will be your answer. So y prime equals, and then you can just rewrite this right side again. And that should be good. We'll get you going on implicit differentiation.